All right, this is part 3 of the midterm practice review test. So we're looking at number 17, which says to analyze the graph of the following function. We have h of x equals x cubed minus 125 over x squared minus 81. One of the things we'll want to do to make the analytical part a little easier is we'll want to factor everything completely. So the top is two perfect cubes separated by a minus sign. So when you factor two perfect cubes, you get a binomial and a trinomial. And the pattern is that you need to know the cubed root of both of these. So the cubed root of x cubed is x. The cubed root of 125 is 5. So in our first part, the binomial is just x and minus, because that's the sign in the middle, and then 5. So every time you keep the root of each and the sign in the middle. That's your binomial. To get your trinomial, you have to square these individual things in pairs. So x times x times 5, 5 times 5. So that would give me x squared, 5x, and 25. Now the signs on the trinomial have to do with a saying we call SOAP. So the original sign right here, this one right here, the one in the binomial, is same as the original. This will always be opposite to the original, so that'd be a plus. And the last one is always positive. So same, original, always positive. That's SOAP. And then on the bottom, we have this factors into x plus 9 and x minus 9, because it's two perfect squares difference. Okay, so the domain has to do with the denominator only. So the things that are going to get us to have dividing by 0 would be a negative 9 and a positive 9. So that makes this first answer B, because that's the one that has the correct values excluded. What is the equation of the vertical asymptotes? Well, there are two, because you have two things that did not cancel in your denominator. So if you solve the first binomial, x plus 9 would give you equal to 0 is x equals negative 9. And the second one would be x minus 9 equals 0, so that would be x equals 9. So we just want to write them with a comma separating them, so negative 9, comma 9. X equals both of those things. Part C, what is the equation of the horizontal or oblique asymptote? Okay, so this one has a top degree, which is your numerator's degree of 3, that is greater than the bottom degree, which is highest power is x squared. Anytime that happens, it's going to be an oblique asymptote, and the only way to find it is to do long division. And usually that's easier to do when it was in its original format. So x squared minus 81 into x to the third. Now I'm going to put placeholders inside because we're missing some powers. That's just so we can line up all of our like terms. So x squared goes into x cubed x times, so I'm putting that in the x column. We would then multiply that by everything out front, putting it in the correct columns. When you do long division, you have to change your signs. That's the subtraction step. So this would still be 0x squared, which we don't need to bring down. This would be 81x minus 125. So for this piece right here, it looks like we do not get to go any further. So this goes in 0 times. X squared cannot go into something smaller than itself. So this is the equation just y equals x. There's no need to write the plus 0. And that would be our A part. And then we need to find the graph that matches this. So if you notice, we've got this one has a vertical asymptote at negative 9 and positive 9, and they all look like they have their vertical asymptotes in the correct location. They have y equals x. That is a line that goes to the origin and has a slope up 1 over 1. Looks like all three have that. So the piece, you can't really throw anything out based on the fact that we had those asymptotes because they're all located in the correct location. Some things we can note is the x-intercepts. So the x-intercept, first of all, x is at 5. This right here, and when you do a perfect cube factoring, this should not be something that factors nicely. So it usually does not give us x-intercepts, and I can prove that to you looking at the discriminant of the quadratic formula if you wanted to do that. B squared minus 4ac. Notice this is 25 minus 100. This is a negative under my square root. That means it's imaginary. Imaginary numbers are not on our xy axis. They are not real numbers. So x equals 5 is the x-intercept, which it looks like this one is touching. It's really hard because I can't zoom in on them. This one's touching at x equals 5. This one's touching at x equals 5, but this one is not. So at least we can throw out C just from information of how we factored things. So the big thing is we're going to have to check, and I'm missing a graph, I think. Oh no. It actually is choice D. I'm missing one of the graphs, so I don't know why it cut that off, but I will graph in just to show you what D looked like, and it's going to be a rough graph. So we have -9, we have +9, dashed lines, and we had the y equals x, which is, I'm just kind of rough estimating where that is. And then the graph that they had was that it was down in this corner and up in this corner. This is what D looked like. And then in the middle, it touches at 5 over here and goes down forever. And then it comes up, does a little jaunt over, and then up forever. So this is what D roughly looks like. I know that's horrible, but yeah, since it's not on our picture, I needed to draw it in. So if we wanted to do a table of values in our function, things that I would focus on is that -9 was a vertical asymptote. We had 5 was an x-intercept. We had 9, which is a vertical asymptote. So any x-intercepts or vertical asymptotes are points of interest, and we want to find ordered pairs on either side of those. So like I would want to plug in -10. I would want to plug in maybe 0 and maybe 4, something in between here, but this is a pretty big gap. I would probably plug in 8 or 7, and then I would probably plug in 10. So you would want to go through on your equation, which was x cubed minus 125 over x squared minus 81. It's usually easier to plug it in before you factored it. And we would do these individually. So this is, if you don't know anything about the end behaviors and stuff like that, this is the best way to get the graph, is just to do a little rough sketch with your ordered pairs. So -10 cubed is going to be negative. It's -1,000 minus 125. So -1125 divided by, if you square -10, that'd be 100. 100 minus 81 is 19. So this is 1125 divided by 19. This is about -59.2. which is way down, which, just to show you why that was helpful to us, if you look at all the graphs, this is positive. We plugged in -10, we should have been getting a negative number. So this guy's out. This is also plugging in -10, and this is positive. That throws this guy out. This is the only one that has -10 far down in the negative. So, you don't have to continue at this point. Since we're not making you graph these by hand completely, you're really just trying to pick the correct graph out of the pieces that you have. So if you plugged in 0, you would have gotten -125 divided by -81. So I can at least show you what that would have been, so you can see that it's consistent. So it's going to be positive because it's a negative divided by a negative, but that's about 1.5, which if you look, that's, roughly, we didn't put any tick marks in. This also would have been wrong. This one would have possibly been arguable that it could have been at 1.5, but that one is definitely in the positive. So D is the answer. And I'm sorry, I didn't know that that graph was off the grid. I'm sure there were other ones that had that same issue. So 18 is a difference quotients problem again. So we have to do the f of x plus h and the negative f of x. So let's do our pieces. So f of x plus h will replace any x in this function. So that would be x plus h instead of x squared minus 7 times x plus h plus 1. We have to FOIL this out since it's squaring. We could go ahead and distribute our 7 if we want, minus 7x minus 7h plus 1. FOIL this out, we get x squared plus xh, so that'd be 2xh's. H times h is h squared. So remember, this is not the whole numerator, this is just the f of x plus h. Then I would do my negative f of x, which just means times your whole original function by -1, or change all your signs. So that's negative x squared plus 7x minus 1. So we take the answer that we got from each of these, So x squared plus 2xh plus h squared minus 7x minus 7h plus 1 minus x squared plus 7x, because I'm on the second one now, minus 1. And we put all of that over h. X squareds are going to cancel out, 7x's are going to cancel out, and the 1 and negative 1 cancel out. So that leaves me with 2xh plus h squared minus 7h. Everything on top has an h, so we can divide it out by 1 on each one. So my final answer is 2x plus h minus 7. And if you're going on to calculus, this will be an important skill, the difference quotient. Okay, number 19 says we want to solve this inequality and then graph the correct solution set. So we'll have to pick our solution set from their multiple choice after we're done. Just to get this said right away, because I'm sure there's going to be another absolute value inequality later that'll be a less than. When you have absolute values, there's two specific setups that we worry about. If you're less than a positive number, and if your absolute value is greater than. And obviously these can be greater than or equal to or less than or equal to. When you're dealing with something inside an absolute value, the problem is that when you report the absolute value, you report it as the distance, so it comes out positive. So when you're saying that your absolute value or your distance from a number is less than a positive number, you're saying that I'm staying, let's call this positive number A. I'm going to keep the inside of my absolute value close to me because I'm saying a distance that is less than A. So I'm either less than on A on the right or greater than negative A on the left. So you're staying close to X. I always think of it as a personal bubble. You can stay inside the bubble. If you're doing greater than, you want someone to be outside of a certain distance. They need to be farther away than a certain distance. So that can happen one of two ways. You could go to your left side and go to A and then go farther to the left, or you could go to the right side of A and go farther to the right. And what that equates to is an OR statement. So either X is less than my left-handed number or my boundary, or, because that takes me to negative infinity, X is greater than the positive boundary on the right side. So that means we're going towards positive infinity. So that keeps my distance away from A bigger than that distance. So we're going like, imagine having a bubble around yourself and no one can step inside of it. So that's what it's saying. You're going further away in both directions. So this case right here is the greater than one. So we have to set up two different possibilities. And you take whatever's inside the absolute value, 6x, and the first case is to say let's head towards negative infinity, so less than negative 42. That gets a left-hand boundary. And then on the right side, we're going to say 6x is greater than 42. When you solve both of these, you're going to get two different solutions, and since they're connected by OR, they're both valid. So, and we want to write our answer in interval notation. So this would be negative infinity up to negative 7, union, because that's the symbol for OR, with 7 to infinity. And we're not including the brackets on anything because there was no equal to. Now, that is our answer for the solution set. The picture would be that we need to pick two opposing, and again, I don't have the graphs for these. I don't know why this did not get all of the graphs. I could try zooming it. Maybe it's because I'm zoomed. No, it just did not get them. These two, I believe, had graphs where it was shaded in between. I don't know which one was which, but essentially that's usually the options. We want this option because this is the one where we're at negative 7, no bracket, and we're shaded to the left, and positive 7, no bracket, shaded to the right. So it is C. Okay, so number 20. This is the big graphing polynomial problem. So this has got a couple different parts that we have to go through and answer. The big idea here is that when you're talking about graphing a polynomial, there's a couple things you want to analyze. You want to analyze something called in behavior, which is if you know your leading coefficient sign, if it's plus or minus, and you know the overall degree if you FOILed everything out in this problem. That's the highest degree of the whole entire polynomial if it was FOILed out. Then that tells us how our graph behaves. So there's a little side chart that when I teach this face-to-face, this always helps people remember this. So you have, is your leading coefficient positive or negative? That's the first thing. And then you have, is my degree even or odd? So that's the two things we want to consider. So if you have an even degree, you're like x squared. X squared has two n values. That means what is it doing as it goes farther away from the center of 0, 0 that go towards positive infinity. So an x squared has a positive leading coefficient. So remember, in a parabola, this is kind of what happens at the ends. Now, if you throw a negative in front of an even degree, they still both go the same direction, but they both head down. If you have an odd function like x cubed, you're going to have, if it's positive leading coefficient, then when you have things that are going towards negative infinity on the x-axis, they're going down forever. And when they go to positive infinity on the x-axis, the y value is also going up forever. So this is what an odd degree function that has a leading coefficient that is positive looks like at its ends. And if we make that negative in front, it just flips the direction. So that is our kind of end behavior chart. So this one has a leading coefficient that is positive. So I always write that down. And this would be squared. So it'd be x squared if we multiplied it out. This is an x to the first if we multiply that out. That is a degree of 3, which is odd. Okay, so it behaves like the most basic odd polynomial, which is x to the third. You don't want to say x to the first because that's a straight line. So when this gets larger and larger x values, it will look like the x cubed ending. Find the x-intercepts and y-intercepts of the function. Well, the x-intercepts are usually laid out for you pretty nicely if they've factored it. You just need to set each of those factors equal to 0 and solve. So this is -4. It says type as an integer or a fraction. So again, they're not making you type them as ordered pairs, even though I wish that they would. So -4 is one of my x-intercepts. And if I set 3 minus x equal to 0, that would just be 3 equals x, so 3. The y-intercept is found by plugging in 0 to all the f or x's in your function. So f of 0 is 0 plus 4 squared, 3 minus 0. This is 16 times 3, which is 48. So the y-intercept is positive 48. Determine the zeros of the functions and their multiplicity. Your zeros are your x-intercepts for us. Use the information to determine whether the graph crosses or touches at x-axis at each intercept. Now this is something else we analyze. So after we analyze end behavior, we will analyze the behavior at each x-intercept or 0. That behavior is determined by the multiplicity or the number of times the factor occurs. So we'll talk about that in just a second, but the zeros are again -4 and 3. So the lesser 0 of the function is of multiplicity. Okay, so this is where you have to be careful. I'm going to write my function again. X plus 4 squared and 3 minus x. So -4 is the lesser of the two. Let me make sure they have that right. The lesser 0 of the function is of multiplicity 2. Yes, okay. So I'm just making sure the sentence actually makes sense the way they've written it. So this is the lesser 0 because it's -4, but it came from this factor. Its multiplicity is the exponent on that factor. So its multiplicity is 2. So the graph of f will touch the x-axis. Now let me explain what they mean by that. I believe they actually say touches. If you have an even multiplicity, you're behaving like x squared at your x-intercept. So you're touching the x-axis, not crossing it. If you have an odd multiplicity, you're behaving like x to the third. So whether it's going this direction or the other direction, you're crossing through. So since this was an even multiplicity, we are touching the x-axis at the x of -4. Now the greater 0 was 3, and it came from this factor, which has a multiplicity of 1, and that is odd, so that multiplicity will cross, which they say crosses. I think you have a drop-down box, and that was at x equals 3. All right, so a couple more questions before we can pick the graph. It says determine the maximum number of turning points of the graph. That has to do with the highest degree we determined, which was 3, I believe is what we wrote down. If we multiplied this whole function out, it would have been an x cubed. So your maximum number of turning points is always 1 less than your degree of your polynomial, your highest degree. So 3 minus 1 would be 2. Okay. And then the last piece is to pick the function. And again, my d is missing. And I have no idea why it did that. So let me graph what D looks like real quick so we can judge which one is the correct answer. So D would have been, it looks like they have it crossing at the -4, or not crossing, sorry, touching. They have it going up. They have it having a y-intercept somewhere around here, and then it comes back through at 3 and goes down. So just kind of giving the general shape. Okay, so let's go back to talk about which one is correct. So remember our end behavior. Our end behavior was a leading coefficient that was positive, and it was a odd degree. So that means that that end behavior is going down on the left and up on the right. So we can go ahead and throw out some functions. Did I miss something on this one? Oh, yes, I did. I'm sorry. Let me go back. This behaves like negative x to the third. Okay, so I am backwards. Sorry, I did not see that this needs to be factored. When you have an x that is listed second, you really should rewrite it and factor it out, that negative. Yeah, I didn't catch that. So that just changes that the leading coefficient is negative, and that means this behaves like negative x cubed. That does matter though for the graph. So anytime your x is not listed first, you need to fix that. So my function should be rewritten as it's a negative then x plus 4 squared. Little details. Now, when I factored this out, I switched the order, so it was negative x plus 3, and then I pulled the negative out. So that still makes it an x minus 3, but this negative has been pulled out to the front. Okay, so let me rearrange this. So this is a negative leading coefficient and odd, so it should be doing this. Just flips the directions. But very crucial, and will make you count it wrong. So you have to be a little bit more detail oriented than I just was. So the reason that was important though is because that throws out B, because it's down on the left and up on the right, and it also throws out C, which is also down on the left, up on the right. So the only two that match the general end behavior shape are A and D. Now, when you look at this does not have both x-intercepts. This has just a single x-intercept. This one has the intercept at -4 and at +3. So A is out, and it has to be D. So I am so sorry for that. Doesn't help that these graphs aren't completely printed either. All right, so that leaves us with just a couple more before the end of part 3. So we have find the real solutions of the following equation. This is a radical equation again. So we need to add over our 2 so we can isolate this radical. 2x plus 1 equals, that would be a 1. Cube both sides to get rid of the radicals. That's 2x plus 1 equals 1. Solve by subtracting 1, so that's 0, so x equals 0. Now the question is that correct? So we have to check it. Because when you use the power rule to get rid of a radical, you get a similar equation, not always identical. So this would just be cubed root of 1 minus 2, so that's 1 minus 2, which is -1. So that does match. So the solution set is the number 0. Okay, 22 is another rational function, so we need to analyze this graph to figure out our domain and range and all of or whatever pieces they're asking for. I usually start by factoring first. Factors of 30 that would give me a +1 in the middle, but multiplied to -30 are +6 and -5. Now, when you're doing your domain, sorry, that's a -6, not a -5. When you're doing your domain, you're only focused on the denominator. So what would make this equal 0 would be a +6. So we do not want to include +6 in our answer for plugging values in. What is the vertical asymptote? That will also be anything that doesn't cancel out in the denominator that has an x as a factor. You set it equal to 0 and solve. So that's x equals 6. Horizontal or oblique have to do with our degrees. So this one had a degree. I'm going to rewrite the equation. And usually when I do horizontal or oblique, I look at the original. Unless something cancels out, then I would look at the reduced function. But nothing in ours canceled out so far. So x squared plus x minus 30 was the original. And we're trying to divide that by x minus 6. So if the degree on top is bigger than the degree on bottom, it is going to be oblique. And it is going to be something you have to do long division to find. If the degree on top and the degree on bottom match, it's just the leading coefficients, and it would be horizontal. If the degree on top is smaller, it's just y equals 0. So you have to check those pieces each time. So x times what makes x squared? It would have to be an x, and then we get x squared minus 6x when we multiply x times everything out front. In long division, you change your signs. So this is 7x minus 30, and then x times what makes 7x? That would be a plus 7. Now, I don't even need to finish this because all we care about is the actual mx plus b when it's oblique. So x plus 7 is our oblique asymptote. Okay, so now we need to pick this from the choices here, and I think there's a D missing again. This messed me up on all of mine. So let me graph D. And I don't have D on the picture. Okay, so my answer key for these doesn't have D, the D graph, so I'd have to go to my math lab. It's not going to be D, so let's just talk about why it's not some of the other ones. Our vertical asymptote was supposed to be at 6, so this is possible. This is possible. This one is not because that's at -6 for that vertical asymptote. The equation's slanted asymptote has a slope of 1/1, which means it should be a positive slope. And that means positive slopes are going uphill from left to right. So it can't be A because that one has a slanted asymptote that is negative. So it has to be B. I'm sure D also had a failing reason. But if you did have both of those correct in B and D, your next choice would be to check maybe an ordered pair on the left side of the vertical asymptote and an ordered pair on the right side to see if it's below or above that slanted asymptote for your points. But B ends up being the correct answer. Okay, so Trent can deliver his newspapers in 20 minutes. It takes Lois 60 minutes to do the same route. How long would it take them to deliver the newspapers if they work together? So this is what we call a work rate problem, and unfortunately we don't have a way to talk about people taking breaks during a job, so we have to do what's called uniform work. And what that means is Trent works at the same consistent speed the entire 20 minutes. That's the only way we can work out this type of problem using algebra. And Lois is going to work at the same exact speed with no breaks on her whole 60 minutes. So because they're working at different speeds, we need to somehow get it into a single minute. What did they do in 1 minute of time? So if you think about it, if it takes Trent 20 minutes to do his job, every minute he did 1/20th of the job if he's working at a consistent pace. And Lois took 60 minutes, so every minute she did 1/60th of the job. I'll put of job per minute. Now together, which I like to call the combo, we don't know how fast they're going to work, so it's going to end up being 1/x. It has the same format. They're going to do 1x of the job per minute. And then it becomes really simple once you've got this set up. It's just to take the two single people working together, which means we add their two individual rates together, should equal the combo. Now, if you want to solve this quickly, I would just get a common denominator over here. So this would be 3/60. I would multiply top and bottom by 3, plus 1/60 equals 1/x. That would be 4/60 equals 1/x. You can reduce this. That would be 1/15 equals 1/x. Then we cross multiply, so x equals 15. So it takes 15 minutes to do the job if they work together. Okay, and then this is the last one on the part 3 video, is number 24. So it says, using the given graph of the function, find the following information. So find the intercepts, the domain and range, the interval on which it is increasing, decreasing, or constant, and whether it is an even, odd, or neither function. So the intercepts on this one, since they did say write it as ordered pairs, we need to write those as correct ordered pairs. So the x-intercepts are -π, 0. We also cross at 0, 0. And it did say use commas to separate each answer. And then at π, 0. Now my domain is all the x's that are being used in the entire graph. So it looks like we're using anything from -π to π. And we are including those endpoints because they are not open circles. The lowest our graph gets is -6. The highest the graph gets is +6. So that's my range. And again, those values are included. They're not open circles. the graph is increasing or decreasing. Okay, so this is where I'm going to write this on here. If it looks like you're going downhill, then you are decreasing on those x values. And it is on the x values that we're looking at. We're talking about as our x's are going from left to right, our y's are either going uphill or downhill. So we're decreasing from here, from negative pi over 2 to pi over 2. The graph is going uphill consistently, so that's an increasing region. And then from pi over 2 back down to pi, on our x-axis, we are again going downhill. So it says we are increasing on, and usually when we talk about increasing and decreasing, we do not use brackets. It's a concept that your endpoint is not doing anything. You have to have 2 points compared on each side to be able to say it's increasing or decreasing. So negative pi over 2 to pi over 2 was the middle part, that increasing section. And then we have a union for our decreasing. So the graph is decreasing on, it was negative pi, 2 pi, negative pi over 2, unioned with, and actually they don't want us to union it. It says you have to read your directions on all my math lab. It says type in your interval notation, exact answer using pi as needed, use a comma to separate the answers. So normally we would do unions, but they specifically asked for commas. And this is, again, one of those places where if I was looking at your answer after the midterm exam and you had a union there, I would still know that you knew the answer. I am not a computer. I can read. So it says, on which interval is the graph constant? It was never constant. It never was flatlined. Now, this function is either neither even nor odd, odd or even. So you have to know what that means. Even means you have y-axis symmetry, which means if you fold across the y-axis, the graph matches exactly. We do not have that. Odd means if you fold double, so fold across the y-axis and then across the x-axis, and that's what we have. Another way to check for odd is that every ordered pair, the exact opposite signs, is also on the graph. So this one is an odd function, which means it has origin symmetry. So odd. Okay, so that is the end of part 3, and I have just one more remaining part that I'm going to record for you guys.